Have you ever looked at the corner of an angle and thought, wow, that's a perfect 90-degree angle? But now let's divide this angle into two smaller angles. And we know that one section of this divided angle is 35 degrees and the other section is unknown in measurement. So how can we find out how many degrees this other angle is equal to? And that's what we'll be talking about today. Hi, my name is Sreenivas, and today I'm going to be teaching you how to find missing angle measures using the rules of complementary and supplementary angles. So let's go back to this example. If a right angle measures to 90 degrees and one section of that angle is 35 degrees, the other part is unknown, and we can call this part x. Because these two angles add up to 90 degrees, if one angle is 35 degrees, then the missing angle should be the total, which is 90 degrees, minus the known angle, which is 35 degrees. And therefore, we should be able to find whatever the missing section is. So 90 minus 35 is equal to 55 degrees. Therefore, x is equal to 55 degrees. Now, there is a name to angles like the 55-degree angle and 35-degree angle. There's a certain name for these types of angles, and they're called complementary angles. And complementary angles are when two angles sum is equal to 90 degrees. Now, there are two formulas we can use to determine complementary angles depending on the situation. So if we are given the measurement in degrees of two angles and you're trying to determine if they're complementary, then you would do angle 1 plus angle 2 is equal to 90 degrees. If both angles sum is equal to 90 degrees, that means they're complementary. But if their sum is like 95, then we know that's not a complementary angle. But if we're given one angle and we're trying to find a missing one of a complementary set, then we would do 90, which is the sum that these two angles need to be in order to be considered complementary. So if we do 90 degrees minus whatever the known angle's measurement, that should equal the complementary angle of the known angle. So the total, we know that's going to be the total if they're told to be a complementary set, or it's told to be 90 degrees, then we have the total minus whatever we know equaling the complementary angle to that known angle. Now, what is another way that we could look at this? So, if we drew a triangle and one angle of this triangle is 60 degrees, or if we switch them, because that looks more accurate. So if one angle is 60 degrees and the other is 30 degrees, would these two angles be considered complementary since 30 plus 60 is equal to 90 degrees, but they don't look the same or aren't like next to each other like in the previous example? Can they still be considered complementary? And the answer to that is yes. Complementary angles can be adjacent or non-adjacent. And what these words or terms mean is adjacent is when, so like adjacent angles are when they're next to each other and they share a side. Non-adjacent angles are separate. But if they're non-adjacent and complementary, then they should add up to, these two angles should still add up to 90 degrees, just like in this case here. So complementary angles can be either one. But now let's try something else. So if we draw another triangle and we have this interior angle, which we can call A, and we're given this straight line extension, and we're told that this exterior angle is 85 degrees. How can we find out what this interior angle is equal to in degrees? Well, we should know that a straight line's angle is 180 degrees in total. Meaning in total, as we can see, it's a straight line. In total, this is 180 degrees, equal to 180 degrees. So we're given that this exterior angle is 85 degrees. We can apply the same steps that we did in the prior example, since we do know what the total amount of degrees this line is in total. So we can apply those same steps. So we know in total it's 180 degrees, and we have the known part, which is 85 degrees. Therefore, we can find A, which is going to be 95 degrees. And like the other example, there is a certain name for these types of angles, and they're called supplementary angles. And that is when two angles sum is this time equal to 180 degrees. And similarly, like in complementary angles, the formulas would be along the lines, if you're trying to figure out if the two angles are supplementary, then angle 1 plus angle 2 should equal 180 degrees. But if you know one angle's measurement in degrees, and you know that it's a straight line or is a supplementary angles pair, then you can do 180 minus the known angles measurement, and that should give the supplementary angle to that known angle. And just like complementary angles, supplementary angles can be adjacent or non-adjacent. But now, how do we not mix up these two concepts? So to remember what both of these rules do, there are many ways to do that. So one way to remember is C, like in complementary, comes before the letter S, like in supplementary. And we remember that 90 comes before 180 when you're counting numerologically in like a numerological order. That 90 comes before 180. So you can just group it by which ones come first to which ones come second. Another way to remember it is also that the C in complementary, you can like create a 9, so you can remember like 90, and the S in supplementary, you can create an 8 and like remember it's 180 degrees. So yeah, those are two ways you can remember it, but there are surely probably more. But now let's talk about why complementary and supplementary angles are useful, because basically these two rules can help us understand how angles fit together into shapes. Like, for example, many shapes like squares, that's not square, like squares, rectangles, and triangles have right angles, which are like 90 degrees, and straight lines or angles like that. Since it's a straight line, these two angles added up would be like 180, or if we did an extension like here, these two angles would add up to 180 as well, 180 degrees as well. So knowing how angles add up lets us figure out missing measurements when we need to with the information we're provided. So, like, for example, if we look into another interesting example, so for instance, we're told that this line EB is a perpendicular bisector to the line AC. And for one angle, there's a let's change this. So we can say there's a ray going through this angle, and we're told that the measurement of one part of this angle is 25 degrees. But we need to find out how many degrees the missing one is, right? And so how can we do that? And we can use the rules of complementary and supplementary angles. But in this case, it would be complementary because when a line is perpendicular to another line, we know like the angles between are going to be all equal to 90 degrees. So therefore, we at least know that the angle is 90 degrees. So these two angles, the 25-degree angle and the one we can call now B, are complementary angles, but we just need to figure out what B is equal to. So we can use one of the formulas that we learned, 90 minus known angle is equal to complementary angle. So 90 degrees minus 25, what we know, 25 degrees, is equal to 65 degrees. Therefore, B would be equal to 65 degrees, using that rule of complementary angles. So, to wrap this up, complementary angles are two angles that add up to 90 degrees, and supplementary angles are two angles that add up to 180 degrees. And they can be adjacent, they both can be adjacent or non-adjacent. We can find missing angles by subtracting the known angle by either 90 or 180, depending on the situation. But essentially, these concepts can help us understand how shapes and angles work together and how we can use them to figure out certain problems. So yeah, that's it. Thanks for watching.